Hello, welcome to this lesson where we're going to be looking at distance time graphs. So by the end of this lesson, hopefully all of us will be able to interpret distance time graphs. So that's looking at the graph and knowing what different things in it mean, and then also to be able to calculate the speed over different segments. So to work out between here and here, what speed is being traveled at. So we have looked at distance time graphs already. These just map the distance from a point, so say our starting point, over a given time. So here's an example of a distance time graph, and we're just going to look at what we do remember from when we looked at them before. So we'll start off by remembering what goes down this axis here. Okay, so down this axis, we put our distance. So this is our distance from our starting point. Now, what goes along the x-axis or the horizontal axis? So here we put our time. So these could be our hours, this could be 1 hour, 2 hours, all the way up, maybe 8 hours up here, etc. Now, on our graph, if we're getting taller and taller, what does that mean? Yep, so when we're getting taller, it means that we're getting further away from the starting point. So our distance is going up, so we're going further away. Now, what does a point like this point here or this point here mean? Yep, so at either of these points, we have been moving away from home and we've turned around and now we're coming closer toward our starting point. Likewise, this point here, we've been moving closer towards and now we're going away again. The tilt of this space here and this space here, I might label this 1 and this one 2. Now which one are we moving faster during? So we're moving faster at 1, so it's this part here, because it's a steeper gradient. So we're moving further away at a faster distance. All right, now we'll move on to some new content. So in this lesson, we're going to look at how we would calculate the speeds of different sections of our distance time graphs. And to do this, we're going to use this formula, which you've probably seen before. Velocity, or speed, equals distance over time. Now we're going to start with an example, and then you'll have an opportunity to do some for yourselves. So we're going to start by finding out what the velocity is of this orange section. Now we need to remember our formula. Velocity equals distance over time. So we're trying to find our velocity, so we need to work out what our distance and time is. Now we can look at our map and we can see that we've started here and we've ended here in our orange section. So we've gone from 10 to 90. So we've gone all this distance, which means that our distance is now 80. So we've traveled 80 units in whatever time we've been given. To find out our time, we need to look along the x-axis. So just draw from each end of the orange section down here, and we can see for this question, we're just going to say that this is 1 unit of time because we've traveled 1. So we would write a 1 here, which would then give us a velocity of 80. So if this was in meters, and this one is in hours, we could say that we've traveled 80 meters an hour. Okay, so now you have a turn to work out what the velocity is of the orange section. All right, so we begin by remembering our formula. Velocity equals distance over time. And we're going to try to work out what our distance and time is. So for our distance, we do these lines, we do similar ones here, and we're going to go from about 90 down to, let's say, 35. So we're going to have a distance of 90 minus 35. And we're going to put it over our time. So our time, we go down here, we go from just after 2 to just after 3 hours. So we're going to say this is 1 hour. So we can then finish our calculation, and we're going to have 45. Remember our units, meters per hour. Here's another opportunity to work out what the velocity is of the orange section. Okay, so once again, our formula, velocity is distance over time. We're going to find our distance and we're going to find our time. So distance, we begin here at about 35, maybe just after it, but we'll say 35 because that's easy. And then it goes down to 0. So we've traveled 35 minus 0, so we've traveled 35 meters. And then over our time, go down here and here. So we've gone from 5.5 to 7.5, so we've gone for 2 hours. So we divide this by 2. Then we can simplify this. We get 17.5 meters per hour. I hope that's made sense, and we'll continue to look at these in class. Thank you.